Good afternoon and welcome back to Embedded World. I'm Rich Nass of Embedded Computing Design. We're in the Embedded Computing Design booth here doing our podcast. My guest now is Fabrizio DelMaffeo. You get it right?
Yes, correct.
There
Thank you
go.
for having me.
And he is with Axelera AI.
Yes.
Couldn't be more of a timely topic. AI is everywhere. But what I want to talk to you about is something that I find super interesting. The move from the cloud to the edge. Most of the applications that we've seen, whether they were done last year, this year, or next year, they really needed to be done at the edge, but we didn't have the performance available. So I assume you're seeing that performance is now available at the edge?
It's correct, completely correct. I mean, we believe in a continuum of computing, essentially computing expanding from cloud at the edge. People sometimes tend to say it's better cloud or the edge, depends on the workload. But reality is that it was not possible until a few years ago.
When you say not possible, doing it at the edge?
Doing at the edge. It was not possible doing at the edge because technology was not there. You could not have enough computing at low power consumption and low cost that is required in the physical world, in the edge devices. And at Axelera, we are enabling this scenario. We build up our company around this concept of enabling the physical AI, the physical world, giving intelligence to all the machines around us.
Go deeper. What is it exactly that you guys do?
Well, what we do is an accelerator, very well optimized to accelerate inference inside edge device. The first chip is a Metis. It's in the hands of more than 500 customers. It's a small accelerator of 214 TOPS, tera operation per second, with typical power consumption of 5 to 10 watts, then very low power consumption. And you can get an M.2 module, which a card that you can plug inside your computer with €250. Then it's also affordable. You have everything to deploy at scale physical AI in edge devices.
So would that sit next to an MCU, or is that
we
the
are
MCU?
Complementary. I mean, you have to think about us like the graphic card of NVIDIA, right? We think that a lot of customers they have a legacy, software legacy. They use Intel, they use AMD, they use NXP, or other platform. What we do very well is to accelerate and offload anything related to AI to our accelerator. That we are complementary. We believe in this, in coexisting with the other CPU companies.
That's a different approach than most people are taking, where they think they should do everything.
Absolutely, but we believe that AI requires very specific processing power, very specific access to memories. If you go to large language model, if you go to vision model, you need more memory. It's better to keep separated this. The CPU can have its own workload, and the AI workload can run efficiently in our accelerator. Like it happens in gaming, where you still have a graphic card, right? Then I think it's going to be like this almost.
And then how do you handle the training for something like that?
We, like everybody, we are using NVIDIA, we are using AMD. Then we believe that training will happen in the cloud. You can still use all your tools for training models, but when the model is ready, we give the tools to port it in a very simple way and run it efficiently inside our edge device, inside a physical device.
And is the technology here today?
Absolutely. We have we have a booth in Hall 5. We have all the demos, customer demos. We show the technology deployed at scale in the real world, and we show that with a very small chip, you can unleash thousands of applications.
And is there a particular application that this is most suited for?
Computer vision. Computer vision is definitely represent 80 to 90% of our applications, but it's also true that you can enable a small language model with the first chip and which is called Metis, and it's available. With the second chip, which we are going to deliver to customer in Q3, called Europa, we are going to enable also large language models inside edge device.
That's awesome. Thank you very much.
Thank you very much for having me here today.
That's Fabrizio DelMaffeo. He is with Axelera AI, and I'm Rich Nass with Embedded Computing Design.
Thank you.